Okay, so we're recording, and we're actually recording starting from the beginning of the class for once. I didn't forget. It's a miracle. So, in the last lecture, we just started talking about, well, we've been talking about functions, but more specifically in the last lecture, we discussed specifically quadratic functions. So, quadratics have been a recurring theme in this class. We've talked about, factoring quadratics, then we talked about quadratic equations, and now quadratic functions. So as you can see, it's just a recurring theme, and they're all fairly similar. Whatever you learn with one generally transposes to learning with the others. So, it's part of the lecture was a refresher, part of the lecture was new material. So, what questions do you guys have for me? And if you guys had questions on number 40, that's good. I want to save that for the end. We'll talk about that together. So I'll save, 5 or 10 minutes towards the end just to make sure that we can talk about question 40 together. So what questions do you guys have that aren't about question 40? 63 and 20. Sure. Okay. Why don't we start with 20 just because, going incrementally here in order. Okay. So number 20. Number 20 says we are looking for a function in the form of f of x is equal to ax squared. Right? This is what we're looking for. If I could write properly, that would help. Ax squared. Okay, so this is what we're looking for, and we know that it goes through the point. Ooh, where am I going? It goes through the point -3, -6. So that means that -3, -6 is a solution to our function. So what we have to do is we have to figure out what this a is. And the way that we figure out what the a is, well, we have an x and we have a y that we know are solutions to our function. So if we plug those into our function, or if we plug those into our equation, rather, the only variable that we'll have to solve for is a. So what we're going to do is, well, we're just going to be plugging in -3, -6. And the way that you could start this off, if it's not readily, immediately understandable, is first start by going back to an equation form instead of it being in a function. So start with y is equal to ax squared. Remember, you can freely go back and forth as long as it tells you that your graph is a function. So as long as your graph is a function, you can go back and forth in that notation. Totally okay. So we have y is equal to ax squared. And once again, we're going to be using the solution that was given to us. So -3, -6. So we're going to plug that in. And -6 was the y. So we're going to have -6 over here. A times, and now we have x squared, but instead of x, we're going to be using -3 squared. So -3 squared. And now notice how the only variable that we have left is a, and once we've solved for a, then we will in fact have a function. We solve for a, we plug it back in over here, and then we're done. So let's solve for a. Solving for a means first we have to take care of this square, so -3 squared. So we have -6 is equal to a times, well, -3 times -3 is +9, right? So we get +9 over here. And now that we have +9, we can just divide out the 9 from both sides. So dividing 9 on both sides, we have -6 over 9 is equal to a. And simplifying this, we get a is equal to -2/3. So again, just really quick to recap before I put my final answer here. We know that we wanted something in this form. So we start with that equation. We were also given the solution, or a solution, to our function. So we use one of our solutions, and for the record, this would work out if we use any other solution as well to this function. I don't know what the other solutions are, but if we were given multiple solutions to this function, or if we had multiple points for this graph, then we could use any of those points, solve, and a will always come out to be the same thing. Okay, but in this case, we were given just the 1 point, so we were given -3, -6. We plug those into our x and into our y. We solve for a, and now that we have finally solved for a, we can write our final answer. So our function is -2/3 x squared, and we're done. Does anybody want me to go over this again? Any questions on this, on how you find this, on what your procedure is? Again, you start with your point, you start with the form of the equation that they're telling you to solve for, and you go from there, right? You just solve for whatever your missing variables are. In this case, our only missing variable was the A. Okay, so I'm going to go ahead and assume we're all good with that. That one wasn't terrible as long as you understood the procedure there. So let's move on to 63 here. So let me clear this. 63, what is 63? It's a great question. 63 was, we were given a function. So our function is f of x is equal to x squared minus 2x plus 4. So we were kind of tasked with a litany of things that we have to do. One of the first things that we have to do is determine whether or not the graph is opening upwards or downwards. Then right after that, we have to find the vertex of the graph. And the reason that I included the the point as HK, but as being defined by a certain set of equations, is because that way it makes your life easier, and you don't have to put it into standard form, right? Nowhere in this question does it say you have to put it in standard form, so why do more work than you have to? You can use that, the second method that we talked about in the lecture video for finding the vertex, which is, that negative b over 2a, and then plugging in whatever you find for h back into your function, and then you get an answer for k. So we'll do that in just a second here. But before we get to that, let's figure out first whether or not the graph opens upwards or downwards. Okay, let me call on somebody here for this. Let's see, Jacob, if you can help me out. What do you think the graph is going to open, upwards or downwards? Actually, before you even answer that, tell me, what is it based off of? Opening upwards or downwards? Okay, Jacob? Okay. So if no Jacob, no problem. Kayla, are you here? Can you go ahead and answer this for me? Basically, again, what is the graph based off of, regarding opening upwards or downwards?
I'm not too sure. Would it be downward?
Okay, so it's going to be based off of A, and A is, remember, it's going to be our coefficient to our highest power, which in this case is x squared, right? So what is my coefficient for this right here? What's that hiding number?
Wouldn't it be 1?
Yes,
Okay.
exactly. It's a 1. Yeah. So, okay, so it's a 1, sure. And now, if it's positive, we know it opens upwards. And if it's negative, it opens downwards. So is 1 positive or negative?
So positive, so it would open upwards?
Yeah, exactly. So we know that A is equal to 1, 1 is greater than 0, 1 is positive. So as a result, this is opening upwards, which is going to look, going to graph something like that. Okay, as opposed to, and I'll draw it in red just so we're all on the same page, as opposed to opening downwards like that. So it's not doing that. Okay. Yep, and Jacob, no worries. Mike wasn't working. Sometimes it'd be that way. Okay, so we figured out the first part, right? Now we know it's opening upwards. Next step is find the vertex. So the vertex, once again, is in the form of hk. And we know that we can solve for h and k, respectively, by doing the following. We find negative b over 2a first, and then after we find that, then we plug in that answer into our function. And whatever we get back out from our function, well, that's going to be our k. So what are the letters b and a referring to? Once again, you have to remember a quadratic in general form is always going to be this thing right here, right? ax squared plus bx plus c. So when it says the letters b and a, they're talking about the coefficients to x squared and the coefficient to x. So a is always going to be your coefficient to x squared, and then b is always going to be your coefficient to x. So we already discussed what the coefficient to x squared is. It's a 1, right? We just talked about this. We know that the hiding number there is a 1. So when we start solving this, we know we're going to have negative 2 times 1 on the bottom. So we just need to talk about what b is. So what is b? Well, b is going to be the number in front of the x, so that's going to be the negative 2. Remember to drag the sign down with it, right? It's not just a 2 that you're bringing down, it's the negative as well. So it's a negative 2 that's coming down. So we know that this is going to be negative 2 over here. And we don't know what f of h is yet because we haven't solved for h completely. So f of h, we just bring down so far. Okay, so what's going to happen here? Well, you have negative 2 divided by 2, which gives you a negative 1, but there's already this negative on the outside of it as well, right? So 2 negatives are going to cancel out, which means you're just going to get a positive 1. So now we know that our x component for our vertex is a positive 1. So now what we have to do is we have to plug our h, which in this case is 1, into our function. And once we plug it into our function, which again is our original right here, then we can get some sort of output, which that will be our k. That will be the y component of our vertex. Okay, so if I can call on one more person today to help me out with this, let's see. Luke, if you can help me out. So I want to plug in 1 into my function. So we're going to have f of 1, right? So f of 1, I want you to help me out with solving this. What is this going to come out to? If you want to plug 1 in for all the x's first, totally okay.
So do we plug it into the negative 2 first?
Well, we're plugging 1 in for wherever there's an x in our whole function, right? So let's first start with the x squared, right? Because there's, we're just reading from left to right. So we know that we're going to have a 1 squared because we're plugging in 1 for x. So just keep going from there.
Okay, and then it'll be negative 2?
Yep, because it's negative 2 times 1. Perfect.
And then plus 4?
Great. And now help me simplify this. What's 1 squared?
1.
Great. Minus 2?
Negative 1.
Great. And then add 4 to it.
3.
Great. So we get 3 as our output for plugging in 1. So what that tells us is that our vertex, the y component of our vertex, is 3. So we plugged in 1 because we got 1 from doing this negative b over 2a piece, which is our x component. And then once we get an output, which we got 3, we know that's going to be our y component, our k. So now we have our vertex. Our vertex is 1, 3. So if we were plotting this on the graph somewhere, and I'm just, sketching this, if this is 1, somewhere up here is 3, your vertex is starting somewhere up here. Okay, so with that being said, the next piece is very strongly related to finding the vertex. In fact, you would have to find the vertex first to get the next thing, which is the axis of symmetry. Now, I didn't go over this too much in detail during the lecture video, but for all your vertices, anytime you have a vertex, your axis of symmetry is always going to be just x is equal to and whatever your x component is of the vertex, right? So in this case, our x component is 1. So our vertical line is always going to be defined by that x component, right? When we're talking about a vertical line, we know that the y component is always changing. Again, just as a quick refresher, if I have this for my vertical line, notice that the y component is always changing, but the x component is always the same, right? The x component is the same at this point as it is at that point. So we define a vertical line by just the x component. So we say that this is x is equal to h, or whatever, that number actually is. So as a result, your axis of symmetry is going to be defined by the x component of your vertex, which in this case is 1. So you would say axis of, and I'm just going to abbreviate here, axis of symmetry is x is equal to 1. And that is what defines your vertical line. Again, if we were to roughly sketch this, we know that again, 1, 3, this is going to be our vertex. So our parabola is going to open up upwards. We already established that because of the A. And the axis of symmetry is talking about at what point does, the parabola mirror, right? And it's always straight down the middle through the vertex. So we're talking about this dotted line right here. This is the axis of symmetry. And notice how it goes through the point x is equal to 1. So we just define the line as x is equal to 1. Okay, everybody with me so far? Just want to make sure that this is clear. Your axis of symmetry is always x is equal to whatever your, the x component is of your vertex. So you find the vertex first, and then you get your axis of symmetry. Or if they give you the axis of symmetry first, well, then you know your x component of the vertex. So if they gave you that x equals 1 is your axis of symmetry, then you know your vertex is 1 and then f of 1, right? We don't know, you might not know what k is immediately, but you could find k by plugging 1 into your function, which is, what we did previously. Okay, so that was the second to last piece, and now the last piece is just find the intercepts. But this is nothing new, right? In fact, this was on your midterm, except instead of it being a parabola, it was for lines. But again, it's the same procedure. So when we're finding intercepts, let's start with finding the y-intercept. What you do is you set your opposing variable equal to 0, right? So what we want to do is we want to get it out of function notation. We want to write it in the equation. So instead of f of x is equal to, yada yada, we're going to write y is equal to x squared minus 2x plus 4. And just like I said, the entire idea here to find the y-intercept is you set your x to be equal to 0. So now we have y is equal to 0 squared minus 2 times 0 plus 4. And when everything cancels, 0 squared goes away, the negative 2 times 0 goes away, and we're just left with our constant, right? So we're just left with this y is equal to 4, which, if you're writing this as an ordered pair, you don't have to, but if you're writing this as your ordered pair, it's 0, 4, 0, because for a y-intercept, you have no x component. Okay, so you found the y-intercept that way, and now the x-intercept you do similarly. So now you just have 0 is equal to x squared minus 2x plus 4. And now we just have to factor this, right? So we look at factors of 4, and we say to ourselves, okay, how is this going to work? Are we going to factor this? Is this going to work out cleanly? And in general, probably not going to work out that well. What I recommend doing is either completing the square or quadratic formula, because factoring isn't going to work here. So let's do, just for the sake of it, let's do completing the square, because completing the square was something that we had to do for finding the standard form of quadratics. So it'll just be good practice anyway. So anybody, don't care who can tell me what my tool is to complete the square? I have a specific something over something raised to some exponent. And that's what I know that I'm going to add to both sides, or add in general.
B divided by 2 squared.
Yeah, b divided by 2 quantity squared. That's always my tool for doing completing the square, right? So my b in this case is -2. So that means I'm going to be plugging in -2 over 2 squared. And this simplifies to give me -1 squared, which is just 1. So what this tells us is that, okay, I want to have a 1 with this piece right here that I just put in parentheses. So I'm going to add 1, and whatever I add, I also have to take away, right? If I want to make the equation balanced, if I add 1, I also have to subtract 1, so that way I'm not changing the total value. So we keep this side 0, and we have x squared minus 2x plus 1. And now we're going to put parentheses around those because that's what we know we want to factor. And now we just have the -1, because remember we added 1, so we take away 1, and we have that plus 4, which is, the piece that didn't work out for us. That plus 4 was no help to us, so we just leave it on the outside. Okay, so let's start by factoring what's inside the parentheses first. Who can help me factor? What is this going to come out to be? So we have x squared minus 2x plus 1. We're looking at essentially factors of the plus 1, right? We have to multiply to give it positive, so on and so forth. Anybody?
It would be x minus 1 and x minus 1.
Great, which gives me, if I simplify that,
Oh, x minus 1 squared.
perfect, thank you. So x minus 1 squared, and now I have x minus 1 squared and minus 1 plus 4, right? So that should give me a plus 3. Okay, so I have x minus 1 squared plus 3. And at this point, you could try to, do a couple different things. Why don't we move that 3 over to the other side? So I'm going to have negative 3 is equal to x minus 1 squared. And this is how I imagine if you got this far, you probably would have proceeded. So we've been learning that, okay, one of the standard ways to solve this is just take the square root of both sides, right? So if I take the square root of both sides, what's going to end up happening? Well, I take the square root here, I take the square root here, and I get x minus 1 on the right, but on the left, I get plus or minus the square root of negative 3. Is that allowed? The square root of a negative number? We have an even-powered root, and we have a negative number underneath it. This is undefined. Oops. If I could spell undefined, that'd be even better. Undefined, right? This is not allowed. Taking the square root of a negative number or any even-powered root of a negative number is not okay. We can't do that. So, as it turns out, there actually are no x-intercepts. There are none. And this kind of helps you understand that if you get to this point and you try taking the square root of both sides and you get an undefined location, the only intercepts that you're going to have are going to be found in the complex plane, which we don't care about, right? We're only talking about real numbers. We're only talking about where real numbers are defined. And since we've already established many, many, many times over the course of this semester that the square root of a negative number is not allowed, then yeah, it's undefined, so there are no x-intercepts. Another way that you could go about it, if I'm starting from here, and I'm just going to put an arrow, so from this piece right here, you could, if you wanted to, try to use the difference of squares method, but notice that it's not really a difference of squares. What we needed for difference of squares to work was a subtraction, right? So you could try to make it a subtraction, like force it, and the way you would force it is x minus 1 squared, and what is a plus? Well, a plus is essentially the same thing as two negatives, right? Minus a negative 3. So now you do have a difference, and essentially you could think about this as a difference of squares. So you could write this as 0 is equal to x minus 1 minus negative square root of 3, or square root of negative 3, sorry, and x minus 1 plus the square root of negative 3. But once again, we come to the same issue, right? We get this square root of negative 3, and that's not allowed, and there's nothing else that you can do. You can also verify this the same way using the quadratic formula that you're going to get, because remember what the quadratic formula is. You have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? This piece right here is the part that's not going to work. That's the part that's going to give you problems, right? You have the square root, and eventually when you plug those numbers in, you're going to end up getting a negative number underneath that square root, same way that we got a negative number underneath our square roots this way. So regardless how you did it or how you tried to find the x-intercepts, it's not going to end up working out. So there are no x-intercepts. And that, again, should make a decent amount of sense, because x-intercepts is where it crosses the x-axis, right? And we've already established two very important things. We've already established the fact that our vertex is right around here, right? This is 1, 3. This is my third time drawing this. I don't know why I keep erasing it. So we know our vertex is starting over here. And now if it was opening downwards, this would be a different story, right? I'm going to draw it in red. If it were going this way, for example, this would be a different story, because, yeah, we'd have an x-intercept here, and we'd have an x-intercept somewhere over here. But that's not the case. We've already established that because a is greater than 0, it's positive, it's going to be opening upwards. So it's going this way. And as a result, notice that, well, it's never touching. There's all this space between the vertex and the x-axis. It's never touching the x-axis. So this should make some intuitive sense that, oh yeah, if it's never going to touch the x-axis, I'm never going to have any x-intercepts. So when you try doing it this way, you're just going to get undefined values. Does anybody have any questions on this, on why you can get a y-intercept, but not always x-intercepts, and on the process that we took? Again, if you got to this point where my green arrow is pointing and you just wrote no solutions, undefined, the empty set, whatever the case may be, you have your wide variety of saying that it doesn't work, that's totally acceptable. And if this were on like an exam or something, I would take that answer. So you would just like stop here. Okay, I'm going to go ahead and assume that you guys are okay. Again, the procedure is nothing really new. It's just that this is one of the first times that we've seen so far where our parabola doesn't touch the x-axis. You know, we're not really used to seeing that. We're normally used to having both y-intercepts and x-intercepts. And in this case, we had no x-intercepts. So, okay. So moving on from 63, what other questions do you guys have for me?
Can we do 71?
71, sure. And the beginning of 53, 53. Did I put 53 on there? I don't think 53 was a question. You mean 52? Possibly 52. But yeah, sure. So 71, we'll do that first, and then we'll double back to Deborah's question. So, okay, 71. Let me go ahead and erase everything here. Okay, so we have a function f of x is equal to 2x squared minus 8x plus 3. Okay, and so what we have to do is a couple things. First, we have to determine whether or not the function f has a maximum or a minimum. So max or min. After we figure that out, we have to find that particular value. So we either have to find them, if it's a max, we have to find it, or if it's a min, we still have to find it. And then after we've done that, we find the range of the function. Okay, so before we even get started, one of the things that we talked about regarding the vertex is that your vertex for a parabola is always going to be either the maximum value or the minimum value. And it depends very much on the direction that the parabola is opening, right? If, just to quickly sketch, if I have it opening upwards as such, my vertex is going to be the minimum value, right? Notice how this is on, according to the y-axis, this would be the lowest possible point that the parabola achieves, right? So your vertex would be considered a minimum. However, if it's opening downwards, well, your vertex is the maximum now, because again, notice according to the y-axis, how the vertex is the highest that the parabola reaches. And then any other point on the parabola is always going to be lower than the vertex. So figuring out whether or not the function has a maximum or a minimum is essentially just asking you, does the parabola open upwards or downwards? So that's essentially all it was asking you to do for the first part of the question. So, well, what did we already just talk about as far as this, parabola is opening upwards or downwards? It depends very much on the coefficient of your x squared being positive or negative. So we look, we see that our coefficient of x squared is a positive 2. So a is equal to 2, which is greater than 0. 2 is a positive number. So as a result, we know this is opening upwards. And so, because we know this is opening upwards, one more time, just to quickly draw this, our vertex is going to be the minimum point, which now we have solved the question, the first part of the question anyway, whether or not f has a max or a min. We know that it has a minimum value. Does everybody follow that train of logic so far? I just want to make sure. If you have questions, please ask me now, because, moving onward, it's assuming you understand that, the vertex is a minimum, not a maximum, or vice versa. Okay, I generally give 15 seconds of silence or so, and then we keep going. So, okay, so moving on, we just figured out that the function has a minimum. So perfect. Now we have to find that value. But luckily for us, we know that the value of either the maximum or the minimum, whatever the parabola has, is always going to be the vertex. So the second part of the question, saying find that value, is just saying find the vertex. So, well, it's in general form, it's not in standard form, so the vertex doesn't immediately fall out, but that's okay because we know we can do our vertex being defined by what we did before, right? Negative b over 2a, and then the k is defined by plugging your h into your function, right? So first we find negative b over 2a. So to do that, well, we just plug in. B in this case is negative 8. So we have a negative on the outside. We have a negative 8 up top over 2 times a. A, once again, is 2. So we have over 2 times 2. And we still don't know what h is yet, so we just leave it as f of h for right now. Okay, so simplifying this down, 2 negatives are going to cancel out, so we know that this is going to be a positive number. And then we just have 8 divided by 4, because on the bottom, 2 times 2 is 4. So 8 divided by 4, we know we're going to just get a 2. So now we figured out that h is 2, which means our k value is going to be f of 2. So what that tells us is we plug 2 into our function, and we'll be able to get the y component of our vertex. So let's go ahead and do that together. F of 2, this is going to give us 2 times 2 squared, right? We have an x. Wherever there's an x, I'm plugging in 2 now. Minus 8 times 2 plus 3. Let's go ahead and simplify this down a bit. 2 squared is going to be 4. 2 times 4 gives me 8. So the first piece is 8. Negative 8 times 2 is a negative 16. So now we have 8 minus 16. And we still have that plus 3 lingering around. Simplifying this one more time, 8 minus 16 is a negative 8. Plus 3 gives me a negative 5. So we've now arrived at the conclusion that when we plug 2 in, we get negative 5. So our vertex, the value of our vertex is 2, negative 5. And now you've solved the second part of this question. So first, again, we figured out that it was in fact a minimum, and it's a minimum because our parabola opens upwards. Then to find that minimum value, we realized, oh, that's really just the vertex. And to find the vertex, we use our handy dandy negative b over 2a. And once we find that, we can plug that value into our function to get the y component. So great, we have our vertex. We figured out that it's a minimum. What's the last thing here? The last thing is finding the range of the function. So once again, let's go ahead and just plot this, or sketch it rather, really quickly. So we know that it's going to be somewhere over here, 2, and then way down here, we'll say this is negative 5. Again, I'm just sketching it. Doesn't have to be super accurate. So our vertex is going to be down here, and I'm just going to label it V, just so we're all on the same page. Okay, we already determined that it is opening upwards, right? So the parabola is going like this. I don't know how skinny the parabola is. I don't really care. Again, this is just a sketch. I haven't found my I haven't found the intercepts, so I haven't really graphed this to scale. I don't know where it's crossing the y-axis or the x-axis, but again, not really the point of this. The point of this is just to show that it's opening upwards, starting from 2, negative 5. So with that being said, notice that the range, when we talked about range, we're talking about reading the graph from bottom to top, right? Reading it from the lowest possible value and going upwards from there. So the lowest possible value that it starts at, is negative 5. The parabola never gets lower than negative 5 on the y-axis. However, it goes up forever, right? It's constantly going upwards, and it's in fact going up to infinity. So we can then say the range is from negative 5 to infinity. And this should make sense, and I'll just abbreviate it as range. This is your answer. This should make sense because of the fact that we already discussed in the lecture video that whenever your parabola is opening upwards, so whenever a is greater than 0, your range is always going to be k to infinity. And then if your parabola is opening downwards, so if it's negative, you have the opposite of that, right? You have it coming from negative infinity to a maximum of k. So in this case, we know that the parabola is opening upwards. A is greater than 0. Again, just really hearkening back here, a is this 2. It's your coefficient of x squared. So as a result, our range starts from -5 and goes on forever. So we're including -5 through infinity. Any questions on this one? On any of the parts? I imagine the hardest part is not even the math behind this, but just understanding what the question is really asking you. You know, it's originally saying, you know, does f, your function, have a maximum or a minimum? But you really have to break that down and see, okay, well, what does that really mean? What is that actually asking me to figure out? So to ask if the parabola has a maximum or a minimum value, it's really just saying, you know, according to your vertex, is the vertex going to be the highest the parabola ever gets or the lowest the parabola ever gets? And in this case, it's the lowest that it ever gets. We find the vertex, which really not that bad as long as you remember your formula, the negative b over 2a. And once you've done that, you can then estimate, or you can then find the range of the function, which is just from its lowest possible value up to its highest in any case. So right here, we see that it starts from -5 and goes on upwards through infinity. Okay, so with no questions on this one, you guys have been pretty quiet on this. I imagine this is okay now. We'll go to Deborah's question. So 56. Yeah, so 56 was a good one because we haven't really seen anything like this before yet. So I'm glad that you brought this one up, Deborah. So let's see. We're starting with the function f of x is equal to 3x squared plus 12x minus 7, right? I believe that's what it was. Let me just double check myself. Yes, okay, cool. Okay, so the idea here is, well, what is it asking us to do? It's asking us to do a couple things. So we have to find the standard form of the function. We then have to find the vertex, the axis of symmetry, and all the intercepts, and then graph the function after we do that, right? I'm not really going to concern myself with graphing the function here, just with the interest of time, because I really want to make sure that I talk about number 40. So just for the sake of it, let's just do the first couple things, and the intercepts I'm also going to leave off because you guys should know how to do intercepts by now, I imagine. Again, just set the opposing variable equal to 0 and solve. So let's start first. Find the standard form of the function. So standard form of a function, when it's in general form, that generally implies that you have to complete the square. Now, when we've done this in the past, we were always, you know, starting with a 0 on the other side. So, you know, for example, we would have had 0 is equal to 3x squared plus 12x minus 7. And the tip that I told you guys when we were first learning completing the squares is your coefficient of x squared a 1? If it's not a 1, then you were to divide everything by that coefficient, right? So in this case, if we had an equation equal to 0, you would have divided everywhere by 3, and that would have enabled you to complete the square. But we don't have that luxury here, and the reason we don't have that luxury is because this is in functional notation. And even if it wasn't in functional notation, even if we had a y here instead, that's not going to help you any better. So you can't divide everywhere by 3, which is why I gave you guys the hint to factor the first and second term by 3, and then, and only then, try completing the square from within the parentheses. Okay, so that's exactly what the first step that we're going to do here. We're going to factor the first two terms by 3. So we're going to have f of x is equal to, we pull a 3 out, and what we have left is the x squared plus 4x inside the parentheses. And we have that minus 7 just lingering around. Okay, so to continue, now what I want to do is, underlined in blue, I want to complete the square for that, just, you know, specifically what's inside of the parentheses. So I'm going to come over here, and we already discussed that the tool that we need is b over 2 squared to complete the square. So my b is going to be the positive 4. So we plug positive 4 in, and that gives us 4 over 2 squared, which is 2 squared, which gives us 4 back. So that tells me that what I want to do is I want to add 4 and subtract 4 within the parentheses, because I want this 4 to be in there, but whatever I add, I also have to take away as well. So I'm going to add 4 from within here. So we have 3, and then we're working exclusively within the parentheses here. So x squared plus 4x plus 4. We just have this minus 4 now. But remember, it's inside the parentheses. And the minus 7, again, still just lingering on the outside. So the entire idea, the whole reason that we always add something in when we complete the square is because now we can factor this piece. That x squared plus 4x plus 4, we can now factor that. So now what I'm going to do is I'm going to factor that, and I'm going to have, when you factor it, and I'm not going to really belabor this point, I'm hoping that all of you guys can factor that at this point. We're going to have, oops, not a y, an x plus 2 squared. And feel free to fact check me if you think that this is wrong, but x squared plus 4x plus 4 should factor into x plus 2 times x plus 2, which is just x plus 2 squared. So we have x plus 2 squared on the inside, but we also have this minus 4 that we had inside of the first parentheses that we created when we factored out that 3. So now we just bring down that minus 7. And the last thing that we have to do here, just so that we can simplify everything, is we originally factored out the 3. Now I'm going to distribute that 3 back to this piece and back to the negative 4 that's hanging around on the outside. So what I'm going to do is this is going to be 3 times x plus 2 squared, and then 3 times the negative 4, which gives me negative 12, and then I still have that minus 7 on the outside. Why did you subtract 4 there? So we figured out that to complete the square, we needed a positive 4. So that means that inside of this parentheses, underlined in blue, I wanted to include a positive 4. But you can't just add 4 without balancing the equation. If you just add 4, you're changing the total value of the equation, right? So what I did was I added the 4 that we needed, but I also had to take away the 4 that we added in because we needed to keep this the same. Notice how if you just do this operation here, positive 4 minus 4, it's the same thing as 0, right? It's like I haven't really added anything to my equation. I haven't changed the value. Adding 0 to an equation doesn't do anything to it, right? All I did is I just changed the form of it so that it allowed me to factor. So now, underlined in black, and I'll put an arrow here, I have x squared plus 4x plus 4, and this enables me to be able to factor. So that piece goes on to become the x plus 2 squared, and that subtraction of 4 that we had to include to keep our equation balanced, well, that just comes down. And notice that everything that we did, all the operations that we did, were inside of the parentheses that the 3 is being multiplied by, so you have to make sure that that minus 4 is still within the parentheses. Because if you notice, when I distribute my 3 back out, it's no longer a minus 4, it's now a minus 12. This minus 4 times the 3 gave me the negative 12 when I distributed the 3 back. Okay, so now the last thing that we have to do is we want it in standard form. So we have 3 times x plus 2 squared, and we simplify the negative 12 minus 7, which gives me minus 19. And what does this tell you? Well, in standard form just says this is going to be your h, and this is going to be your k. The only drawback is that you have to remember that when you're pulling your h out of the equation, it's always going to be the opposite sign. So instead of it being a positive 2, you have to recognize that it is a negative 2, not a positive 2. But for the k, it is exactly what the sign says. So k, it says that it's a negative 19, so we directly pull negative 19. And so negative 2, negative 19 is your vertex. So the idea here, once again, the reason that I gave you guys the hint is because I felt it was unfair to just kind of leave you to the wolves without starting you off. You should pull out the 3. Then you complete the square for what is inside, because completing the square is what you have to do anyway to get it into standard form, right? So we complete the square, and the only difference between what we normally do and what we did in this situation is that we had this 3 on the outside. So that 3 on the outside impacted this -4 because we had to distribute that 3 back. So if that 3 weren't there, then that would have made this, a whole lot easier, right? If our coefficient to x squared was just a 1, completing the square would have been much simpler. So I tried to find the vertex before putting it in standard form and got a different answer. Is it because it wasn't in standard form? Are you talking about, Aline, by trying the -b over 2a? Like that thing, and then plugging in once you get an answer, f of h? That should still work out. That should still give you a correct answer. The only reason that we didn't do that is because the directions specifically said get it into standard form. So we wanted to get it into standard form anyway because that's what the directions asked of us. But trying to find the vertex that way should still work out. Double check your math. There might just be a sign error that may be throwing you off. Yeah, it's probably just a small little like sign error that's throwing you off there. So I have 5 minutes left. I just want to kind of get through the rest of this here. So let's see. We found the standard form of the function. We found the vertex. What's left? The last thing that we have to do is find the axis of symmetry. Well, not the last thing, but the last thing I'm going to go over is finding the axis of symmetry. But like we already talked about, the axis of symmetry is always defined by your x component of the vertex because it's a parabola that we're talking about. And a parabola is mirrored around the line that goes through the vertex. So your axis of symmetry is going to be x is equal to -2. Okay, so it's that vertical line that goes through your vertex, -2, -19. And because it's a vertical line, we just define it by x is equal to whatever x value that vertical line goes through. So in this case, it's going through -2, so x is equal to -2. And that's your axis of symmetry. I'm not going to help you guys out with the intercepts, just again, with the interest of time and graphing the function, not, really. It's important, but I don't have time to do it right now. And once you find the intercepts, graphing the function gets fairly trivial because you already have the vertex, you have intercepts, so you have enough points that you can graph it, and I'm pretty confident that you guys can do that. So moving on to question 40, just because I want to get to this. So 40, actually, let me just save myself some hassle. Okay, so 40. I'm going to try to draw this as best as I can. If you want a more accurate picture, please just look at the homework because I literally just have a picture straight from the textbook. So it's going to look like something like this. We know that there's going to be a point there that is a solution to the function. Our vertex is starting somewhere down here. So we have this parabola. Imagine that my drawing was better and the right-hand side was curved. Let me just do that one more time. There we go. Okay, not bad. Okay, so we want to find the signs of A, B, and C. What are A, B, and C? Again, when we're talking about a quadratic function, we're talking about ax squared plus bx plus c. So we're basically saying figure out if A, B, and C are positive or negative, which might seem really confusing and daunting at first, but you actually are given one of them for free because of the graph of the picture, or well, because of the graph, and you can figure out the other two by examining the graph. So the one that you get for free is A, and the reason you get that for free is because, well, the parabola is opening upwards. And what do we know that has to be true about A if the parabola is opening upwards? Well, if the parabola opens upwards, we know A has to be positive. So A is greater than 0. A is positive. You know that for fact. That is just free given to you simply because of the way that the diagram is drawn. So great, one of them is done. The next one's not so easy, right? Figuring out B and C may not be that intuitive. For the record, I know I'm going to run over by a couple minutes. If you guys have to leave, so be it. But I just want to make sure that I get through this. It'll be in the recording, so, yeah. Okay, so for the next pieces, B and C, first let's talk about the vertex. The vertex is always going to be HK, right? What is H? H is your x component of the vertex, right? So H tells you whether or not you're on the left or the right, right? Going on, we're talking about the x-axis. That's what H is considered. So if we're talking about the x-axis, we know that the x-axis is positive over here and negative over here, right? So what sign should h be? If anybody just wants to shout out an answer. What sign should my x? Negative. Yeah, right? So I know that h is negative. And we have a formula that involves h, b, and a. And that formula is h is equal to negative b over 2a. So if I know that h is negative, I have a negative sign here. I don't care about what the value is. I just know that it's negative. And I know that I have that built-in negative sign. And a, we've already established is positive, right? And a positive number times 2, well, that should just give me a positive. So if I know that I'm going to get a negative number back, we're just basically asking ourselves, okay, what does b have to be to make this true? If it's negative, what's going to happen? So just hypothetically, I'm going to write a negative sign here. What happens? Well, you do the division first, right? Negative over positive. That should give you a negative. So this piece right here cancels out to give you a negative. And then negative times negative gives you a positive. So if this were negative, you would have negative is equal to positive, and that's very much not true, right? We see that that can't possibly work. So the only thing that can work here is b is forced to be positive here. This has to be a plus. And the reason, again, is because we know h is negative for sure. We know a is positive for sure. So the only thing in question is the b, the sign of the b, and figuring out the sign of the b is just a, just a simple check here. So we know that this is positive, and again, just to double check your work, positive over positive gives you a positive, and positive times negative is negative. So you get a negative on both sides, and yeah, that works out. So now we have established b is, in fact, positive as well. So b is greater than 0. And the last thing that we have to figure out is the sign of c. But think about it. When you're doing your y-intercepts, which that's what this is, right? This point is on the y-axis, so this is a y-intercept. When you're doing your y-intercept, what does that tell you? When, like, essentially, what is your process for figuring out the y-intercept? Your process for figuring out the y-intercept is making x equals 0, right? So that means that this term drops out and this term drops out, and you're just left with c, which means that if your y-intercept is down here, then c is negative. So for our y-intercept, we see that it's actually positive on the y-axis. So as a result, we know for free, once again, c must also be positive. Because, again, c is our y-intercept. Does anybody have questions on this? Again, this was not intuitive. That's why I said this would be a challenge. And I didn't go over to the lecture video specifically for this reason. I wanted to see if you can kind of test yourselves. But this isn't super important, but recognize that with only the graph of the parabola, you can figure out the signs of A, B, and C. You can figure out the signs of all of the variables that control your, your X's and your Y's. Scroll down, sure. I have no idea how far you want me to scroll down, so I'll just stop right here. In fact, why don't I do you one better? I'll just zoom out. Okay, guys, so again, final answer, they're all positive. So that's it for today. There's going to be a lecture again tonight. Expect another homework. And then come Friday, we're going to have our quiz. The one last thing that I'm going to say before you guys head out, or before all of you leave anyway, I'm sure I lost a couple of you guys when it hit 11:50. I sent out an email, and in that email, there were two things that I hadn't said in the class before that I want to make sure I go on record saying. First off, please just do me the favor. Just give me a little more space when you're writing your answers on quizzes or, tests. Specifically, I'm really worried about the project packet. I have a very strong suspicion some of you who have started it have already kind of like jumbled all of your work on one page, and I'm like really anxious about getting that. So if you can just do me the favor of just spreading out your work a little bit, even if it just means giving me one extra piece of paper that you scan, that's totally preferable than like having all of your work condensed on like 7 lines. And then the second thing, and again, I'm not really sure where, like, anybody thought that this may or may not be acceptable, but let me go on record now and say this is not acceptable. You have to be here in the meeting, in the class meeting, to take a quiz or a test. You have to. The only exception is for people who have spoken to the ARC and sent me their plan, and that, I've approved their plan so that they don't have to be here because they are allowed to take quizzes and tests in a reduced environment, or a reduced stimulated environment. But anybody else, if you've not done that, you have to show up to the meeting every Friday for your quiz to count. Yes, Zanita.
So like, I know like at least like I've been like on during the quiz days, like I've been coming, but then like in the middle of the quiz I leave. Should I just stay throughout the whole quiz?
So if I've seen that you show up for the for the quiz, or I'm sorry, for the review itself, I'd prefer if you stayed, because again, you're still part of the class. It's still like counting as attendance, and I generally take the attendance. Again, I don't grade you on attendance, but I generally take attendance from the point that the quiz starts. So there's a chance that if you've left, as soon as you started the quiz, that when I take attendance, I'm not catching you. So it only helps you to stay in the meeting. And honestly, there's no downside to being here, because if somebody has a question, you might also have the same question. Then I can answer it for everybody. So just stick around in the meeting. I'd really prefer that, as opposed to, people not showing up or leaving halfway through. Okay. And again, that goes like 100 times more for the final. So on the day of the final, unless something changes drastically before then, I want you guys to be in the class meeting for the final. Okay? Any questions on that? Okay, awesome. I'm going to stop the recording here. So now I have everything on record. Okay.